Alright, in this video we're going to be looking at single displacement reactions. We're going to do two things. We need to figure out, first of all, whether the single displacement reaction will happen or not, and then if it takes place, then we'll look at completing that reaction, figuring out what the two products are for this. And so for single displacement reactions, what you've got going on in these systems is you're going to have a metal and a compound. And your product is going to be usually a different metal and a different compound then. The only time it won't be a metal is if you've got an acid like hydrogen. If that reacts, you're going to form hydrogen gas. So we'll deal with that one in that second reaction there. All right, so the first thing we want to do now is figure out if the reaction is going to take place or not at all. And so for that we need an activity series. And so I usually supply this with my class. Your instructor might have you memorize the whole thing. Hopefully not, because that's a lot to memorize. But like I said, I usually supply the activity series itself to the class. So here's the activity series. So we're going to answer whether it will react or not. What we need to look at here is the metal that's by itself and the first element in the compound, which is usually going to be a metal here also. And we got to find those on the activity series itself. And so here's magnesium up near the top of this reaction, and iron is just a little bit below. So what you've got here is the least reactive elements are down here at the bottom, and the most reactive elements are up at the top. A more reactive element will displace a less reactive element from this compound. All right, a more reactive displaces a less reactive. So if we look for magnesium and iron on our list here, again, magnesium is higher up than iron. Magnesium's more reactive. The way I usually think of it, magnesium then is able to kick the iron out of the compound. If it's more reactive, it'll kick that element out. If it's less reactive, then you can think of it as not being strong enough or reactive enough to kick that element out of the compound. So it's always the metal by itself versus the metal in the compound. So in the case of magnesium with iron, magnesium's more reactive. The answer there is yes, it will react. All right, we can look at the next system here. It's zinc versus hydrogen. And so again, we can look at our activity series. Here's zinc right here. And again, the only nonmetal they put on the activity series here is hydrogen. And that's this one right here. They put it in its elemental form, which is a diatomic gas, which again, we'll use here in just a little bit. So that's why it's listed there as H2. But that's our element there, the first element in the compound. So just like before, zinc is more reactive than hydrogen. It's higher up on the list. So the zinc here is capable of kicking the hydrogen out of the compound there. So that one will also react. And finally, the last one, I picked one where it's not going to react. I'll kind of give you a spoiler alert on that one. Sorry. And so we've got copper versus nickel. So if we find those, here's copper towards the bottom of the list. Less reactive metals are down at the bottom. And here's nickel more towards the middle of the listing there. So copper versus nickel. Copper is less reactive. And so copper is not strong enough of a metal. It's not reactive enough to kick that nickel atom out of that one. So that one, there's no reaction. And so oftentimes we just kind of write out no reaction there. That means we're not going to do anything else with that. But the other two, the zinc was more reactive. It's going to come in and kick out the hydrogen. The magnesium is more reactive. It's going to come in and kick out the iron. All right, so that's what you need the activity series for, is just to predict whether those reactions will take place or not. I gave some extra information down at the bottom here. We're going to need that for finishing up these equations. So again, your instructor might give you this information, or you might have to look it up if you're working on a homework problem, that sort of thing. But just for the video here, I put it down at the bottom. We need some polyatomic ion formulas and their charges, as well as some transition elements and their charges. Zinc and copper, we can't really easily tell what their charge is based on their location in the periodic table. Some instructors might have you memorize that zinc is a +2, but again, I'm just giving that to you here just so we've got that information. Otherwise, we have our periodic table. The main group elements, we can figure out what their charges are, and non-metal elements, we can figure out what their charges are from their location in the periodic table. So I'll bring that back here in just a second. All right, so what we want to do now is complete these. So the magnesium, as I said for the first one, is going to kick out the iron. So what that means is iron ends up by itself. So we just write Fe there, and we always want to, kind of like we did in some other systems, we just want to bring one of each atom over to the product side first, unless it's a diatomic substance for that. And so then we're going to bring over one magnesium, and now the nitrate ion is going to be with the magnesium. Remember, the magnesium is kicking the iron out. That's why I've got the iron by itself there. And so that's going to give me an NO3 for the nitrate ion now with the magnesium. Now, like you always want to do though for any ionic compound, this is a metal and a polyatomic ion, we need to balance out the positive and negative charges with this. For the nitrate ion, notice I wrote that one out down here, that's just got a -1 charge. I'm just going to write that up above it there. And then magnesium, from its location in the periodic table, it's right here in the second column, so magnesium's going to be a +2. Anytime you've got an ionic, you need to make sure that that positive and negative charge balance out. They don't here. I've got a +2 versus a -1, and so we need to balance that charge out. The quick way of doing this is by that crisscross trick I've showed you in other videos here. We're going to bring the 1 over here. That's how many magnesiums I need. We don't need the negative sign, just the 1, and the 2 on the +2 there for magnesium, that's how many nitrates that I need. Since I need 2 nitrates, I'm going to put that inside a parentheses and put a subscript 2 outside of that. So MgNO32. Sorry, I got over into the will it react part there a little bit. All right, and then the last thing we need to do then is balance the equation. Once we get our formulas right, the metal is really easy by itself. You just need one of those, again, unless it's hydrogen, and then balancing that formula out, we've got that done. Now we can balance the equation. So I've got 1 magnesium over here, 1 magnesium here, so far so good. 1 iron there, 1 iron there, so far so good. But I've got 3 nitrates. You can actually balance it as an entire ion here, NO3 versus NO3. I've got 3 of them on this side with that subscript 3. I've only got 2 of them on this side. So I need to bring those both up to a common number. That common number is going to be a 6. So to bring this 3 up to 6, I'm going to put a 2 out in front of there. That'll give me 2 times 3 is 6 nitrate ions. And then to bring this one up to 6 also, I need to put a 3 out in front of that. 3 times 2 is a 6 there. Then to balance out the other atoms there, the iron and the magnesium were balanced before, but they're not now. I've got 1 magnesium here, but with the 3 out in front, that gives me 3 magnesiums. So I need to put a 3 out in front of the Mg there, and with a 2 in front of the Fe, I need to put a 2 in front of the Fe atom there. All right, so that first reaction's done. All right, let's go on to the second one here. This one's a little bit trickier again with the HCl in it, just because the hydrogen atom does a little bit different thing here. We did already say that this is going to react. Zinc's more reactive than hydrogen. Again, that was from the activity series that we looked at earlier for this one. But when zinc kicks out the hydrogen then, and this is where, again, having the activity series really helps, notice that they've written hydrogen here as H2. Hopefully you can see that on there. And again, you'll have that activity series when you're doing these. And so that helps, hopefully you remember that hydrogen is going to be a diatomic gas, H2 gas there. And then it's the zinc that combines with the chlorine in there. Again, we're going to start with 1 of each of those, and that's all we had on the reactant side, so we don't even need to worry too much about that part of it. But we do need to balance the positive and negative charge. Now zinc, its location in the periodic tables here are part of the transition elements, and those can have a couple of different possible charges depending on which transition element it is and so forth. And so zinc, turns out zinc always has a +2, so you could just memorize that if you needed to, but when you're first starting out, sometimes your instructor will just give you that information like I did down at the bottom here. I said zinc is a +2, that's the common charge in a compound, all right? Doesn't always have to have those charges for the transition elements, but oftentimes you'll be told what those common charges are. So I'm just going to write that +2 up above it there. And then chlorine, that one we can figure out from its location in the periodic table. It's in that second to last column. There's chlorine right there, and they always have a -1 charge. And so as we've done before, when they have different charges there, we need to crisscross that, balance out that charge. I need 1 zinc and 2 chlorines. Again, that crisscross trick doesn't always work, but it does in this particular case. Sometimes you have to simplify it, but here it's already in its simplest form. All right, so that balances out the positive and negative charge there. And then to balance the equation, I've got 1 zinc here, 1 zinc there. That's all set. I've got 1 hydrogen here, but there's 2 on the product side. Remember that elemental hydrogen's diatomic, so I need to put a 2 out in front of that. That gives me 2 chlorines there. Hey, look, I've already got 2 chlorines on the product side, so that's already balanced then for that. And that's the equation then. That's it for that reaction. And like I said, the last one here, we don't need to do anything with. That one's already, we've already decided there's no reaction there, so why bother going ahead and writing it out? I gave us the information if copper was in a compound, but like I said, there was no reaction in that case, so we don't need to do anything with that. All right, and that's how you balance, complete and balance single displacement reactions.